Welcome to the Brainloop Lab. Today we learn basics of Python and Google Colab. Introduction to Python for science students. This presentation serves as an introduction to Google Colab and Python, specifically designed for science students. It emphasizes the fundamentals of coding and explores various applications in biology and chemistry. Additionally, it offers a comprehensive step-by-step guide to empower beginners in their coding journey, ensuring that they can start coding effectively. Why? Choose Google Colab free service. Google Colab is a free, browser-based service that allows users to write and execute Python code. No installation required. No need to install any software. Cloud-based lab. It functions like a cloud-based lab where students can experiment with code. Seamless integration. It seamlessly integrates with Google Drive, beginner-friendly, ideal for beginners. Colab simplifies the coding process, supports data analysis. Colab is particularly beneficial for science students as it supports Python for data analysis. Setting up your Python environment in Google Colab. To start coding in Python, Google Colab is a user-friendly platform that allows you to create notebooks seamlessly. Follow these simple steps to begin your journey. Visit Google Colab. Go to colab.research.google.com. Sign in. Use your Gmail account to log in. Create notebook. Click New Notebook to start coding. Introduction to Python Basics, 1 Understanding comments. Vital for enhancing code, readability. Use the print function. 3 Mastering variables. 4 Store and manipulate data effectively. 5 Using lists. Efficient storage for multiple items. Importance of Python for science students. Python is an indispensable tool for science students, facilitating tasks such as DNA analysis, data visualization, and predictive modeling across various scientific fields. In future tutorials, you will learn to apply Python to real-world scientific challenges, equipping you with essential skills for your academic and professional journey. Data analysis. Analyze complex data sets. Data visualization. Visualize research findings. Task automation. Automate repetitive tasks. Tips for effective code writing. Start small with modifications. Begin by making minor changes to existing code, such as altering variable names or numerical values, to understand their impact. Develop good coding habits. Emphasize the practice of writing code manually, line by line, rather than relying on copy-pasting. Experiment with personal examples. Encourage hands-on learning by adding custom print statements or performing unique calculations within the code. What's next? Analyze DNA FASTA files using Biopython for biological computation. Subscribe to Brainloop. Stay updated on future tutorials. Unlock new insights. Learn coding applications in biology and chemistry. Engage with us. If you enjoyed this video, please give it a thumbs up, share with classmates, and subscribe for more science content. Check the description for tools.